Every once in a while, a single idea comes along that just changes everything. Back in 2012, one research paper didn't just win some competition, it lit the fuse for the entire modern AI revolution we're living through right now. Today, we're going to dive into the story of that paper and a network called AlexNet. Pretty simple question for us humans, right? You probably said a leopard without even thinking. But for a computer, that's a whole different ballgame. For a machine, this is an incredibly complex problem. And that is right at the heart of our story. For decades, you had the smartest people on the planet trying to crack this problem of getting machines to see the world like we do. And honestly, for the most part, they were failing. The problem was just that ridiculously hard. So, this isn't just some dry story about lines of code. It's about a totally radical new approach, a super high-stakes competition, and a result that was so mind-blowing it basically sent a shockwave through the entire tech world. Okay, so let's break this down. What was it about this vision problem that was so ridiculously hard for computers? Why couldn't they just, see? Well, just think about it from the computer's perspective. That leopard could be up a tree, it could be on the ground. You could see it from the side, from the front, in bright daylight, or in a dark shadow. A computer doesn't see a leopard, it just sees a grid of pixels, millions of them. And all that variation makes finding the consistent leopardness in the pixels a monumental, almost impossible task. So to really tackle this, the entire field came together and created the ultimate test, the Super Bowl of computer vision, the ImageNet Challenge. This was a digital Olympics. They put together this gigantic data set. We're talking over 1 million images in 1,000 different categories. And basically said, all right, world, you think you're smart? Prove it. But here's the thing. By 2012, progress had totally stalled. We're talking tiny, incremental improvements year after year. It was like they'd hit a brick wall. Everyone knew that to get a real breakthrough, someone had to come along with something totally, completely different. And then, out of nowhere, this something different arrived. It came from a small team, a group of researchers up at the University of Toronto. They decided to throw out the old playbook and build a brand new kind of digital brain. They were working with something called a convolutional neural network, or a CNN for short. Now, you can think of this as a kind of artificial brain that's specifically designed to find patterns in images, a lot like how our own visual cortex works. The idea itself wasn't new, but the one they built was on a scale that was, frankly, kind of insane. Nobody had ever tried to build one this big before. Look at these numbers, 60 million tunable parameters. That's like having a control panel with 60 million knobs that the network has to learn how to set just right. It was so huge that most people thought it was literally impossible to train. This created two massive problems. One, it would be incredibly slow, and two, it was almost guaranteed to overfit. That's where the model just memorizes the training data instead of actually learning. Kind of like a student who just crams for a test by memorizing the answer key. They might ace that test, but give them a slightly different question and they're totally lost. So how in the world did they pull this off? Well, they had a couple of secret weapons. A real secret sauce with two brilliant innovations that made the impossible possible. First up, they gave their digital brain better neurons. See, the older artificial neurons had this problem where they'd kind of get tired during training. They just stopped learning effectively. So this team used a new, much simpler kind of neuron called a ReLU. And these things were like a student who's always eager to learn. They never got tired, which just massively sped up the whole training process. And you don't have to take my word for it. Look at this chart right from their paper. It shows just how huge this was. The ReLU neurons, they reached the goal 6 times faster. That's insane. Something that would have taken over a month to train now took less than a week. A total game changer. Okay, so for their second trick, they came up with this incredibly clever technique called dropout to fight that memorization problem. Imagine you're training a basketball team, but for every practice, you randomly tell half the players to sit out. The remaining players can't rely on any one superstar. They all have to learn to be more versatile. That's exactly what dropout does. By randomly switching neurons off, it forces the whole network to become smarter and more robust, so it can't just cheat by memorizing. All right, so the stage is set. The Toronto team has their giant new brain, they have their secret sauce, and they enter the 2012 ImageNet competition. And let me tell you, the rest of the research world had no idea what was about to hit them. So how do you win this thing? Well, the main score is something called the top 5 error rate. It's pretty simple. For any given image, did the computer's top 5 guesses include the right answer? The lower your error rate, the better you did. So let's set the baseline. The second place team that year, which was basically the best of the best using all the old methods, had an error rate of 26.2%. And at the time, that was considered really, really good. That was the state of the art. And then AlexNet's score came in, 15.3%. Look at that gap. This wasn't just a win, it was an absolute blowout. They didn't just inch past the competition, they left it in the dust. An improvement that massive, it was unheard of. People were just floored. The game had changed, literally overnight. That number, 15.3%, that was the starting pistol for the AI revolution. It was the big bang for the entire deep learning era that we're all living in right now. And what was so cool was that it wasn't just about the score. When people dug into the results, they saw something amazing. When AlexNet made a mistake on that leopard photo, its other guesses weren't random things like car or chair. No, its other guesses were jaguar, cheetah, snow leopard. It showed signs of actually understanding the concept of a big cat, not just matching pixels. And the authors of the paper knew exactly why it worked. It was right there in their conclusion. They said, the depth really is important. They had proven that the secret wasn't some fiddly little trick, it was about going big. Building deep, complex networks was the future. And that single victory kicked off this incredible chain reaction. First, it proved, beyond a shadow of a doubt, that deep learning was the real deal. From there, computer vision just exploded. And then, these same ideas started spreading to other fields, like understanding language and audio. I mean, you can draw a straight line from this one paper in 2012 to the technology that unlocks your phone with your face, to the systems that let self-driving cars see the road, all the way to the AI tools creating mind-bending images today. You know, every revolution has that one moment, that one spark that ignites everything. For modern AI, this was it. This paper was that spark. Which really makes you wonder, what's going to be the next one?